This is a pretty typical chain rule problem we have here. I'll give you a couple seconds to absorb it while I just copy down the chain rule. Derivative of f of g of x is equal to the derivative of f at g of x times the derivative of g of x. And that first one I used was just Leibniz notation. So here we're given that h of x is equal to this whole mess of f of g of x, and so there we are. We have f prime of x times g of x times g prime of x, and so let's just substitute in the 2 here, and then we'll have our answer. If we look up here in the chart, we see that f prime of 2, oh, sorry, let's start with g of 2, and then we'll work out from there. So we have f prime of g of 2, and g of 2 looks like negative 1, times, let's just leave that as g prime of 2 for now. We'll go and fill in the primes now. So that equals f prime of negative 1, let's see, f prime negative 1, that's 3, times g prime of g prime of 2, it's good, no negative 2. G prime of 2 is 2. That looks like some very nice arithmetic there. Okay, 3 times 2 equals 6. And so we see that the answer is D, or 6. Perfect. Alright, that's problem 90. Now on to problem 91. Perfect. Okay, so let f be given by the function f of x equals, okay, that looks like a right mess. At which of the following values of x does f attain a relative maximum? So, what we know about relative maximum from calculus AB is that f reaches a relative maximum when f prime changes from positive to negative. So our first order of business here is going to be determining f prime. So let me start writing in here an equation. F prime of x equals, I'm just going to pause it here so I can get all the notation right. 1 second. Actually, you know what, it might be a little bit better if I just write out this first step here as, actually, yeah, I'll write the first step out as just f of x. F of x. And I'll be right back with that notation. Alright, so now we have the notation in here. Now I'm going to fast forward a little bit again, just so we can hurry through. The important part to remember here is that when you're taking the derivative, you're looking for the derivative of the antiderivative at each bound. And when you have a non-constant bound, like we do here, we have an x, you just have to be very careful about maintaining that. So let's see, I'm going to pause it again. Okay, so right, what I was saying was you have to be careful of non-constant bounds, and I'm just going to show that I did that, I'm just going to write in the derivative of x here, and that's just 1, because it's dx. And you notice that we leave out the second boundary. That's because the antiderivative of a constant is also a constant, and so when you take the derivative of a constant, it's equal to 0, so we can write that in if you like. There we go, just to be complete. So that's what we're left with here. And now we take out our calculator and we say, okay, we want to know the zeros of f prime of x. So let me just write the setup in here. F prime of x, is x equals 0 at, let's see, so cosine, we're putting in our calculator cosine of 1 over x squared And notice they give us boundaries here. They give us boundaries 1/3 to 1. That's going to be very useful. Otherwise, we'd have an infinite amount of solutions. So solving for when cosine of 1 over x squared equals to 0, and we're going to put a little limit on there to make sure that it does not exceed 1 or go lower than 1/3 inclusively. Make sure it's inclusive because sometimes that can make a difference. We get x equals 0.3568 or 0.4606. And as we can see, we have two solutions here, 0.357 and 0.4606, and so it looks like one of them is going to be extraneous, and that would be, oh, look at that, I missed a solution here. That's our issue. Or 0.7978. There we go. So the extraneous solution in here is going to be 0.4606. If we look at the graph, that's when it goes from negative to positive, and we're looking only for positive solutions. So let me just delete that, and we're left with an answer. And that answer is A. The answer, let's just write it all out. Oopsies, capitalization. It's hard. The answer is A. And that's 0.357 and 0.798. Perfect. Alright, on to the next one. 92, and we see that b of x, so just recalling our product rule, we're going to see b prime, oopsies, let's get this ink in here, b prime of x equals to g prime of f times f prime. And just some easy things we can note before we begin. Y equals f of x, this line here, it looks to me like it has a nice easy constant slope of 1/3. You can do the slope formula for that. So we get oopsies, what's happening here? Get the pen back, right? We get f prime equals 1/3 for all x there, and then we're looking at x equals -3. So the first order of business here, let's take care of one bit at a time. This here, we're looking at g prime of f of x. F of x at -3, f of x at -3 is right here. That looks to me like a really nice little point, -3, 1. So now we're looking for g prime of 1 at 1. There we go. Good. G prime at 1 times, of course, our f prime. And we can just substitute that in right now. Times 1/3. 1/3. Perfect. So we get g prime of 1 times 1/3. And this, again, is a really nice line that they're giving you. Here's 1, and here's our tangent at 1. And they tell us that this is our tangent in the problem. And so we get 1 and 2 right there. So that looks to me like -1/2. -1/2 times 1/3, and that, of course, is B. So it looks like we're in the green here. Alright, bye.